Basically what I'm going to show you is a step-by-step approach to cracking this protocol, which wasn't not very hard, although the product catalog says it's impossible, so that's good. So basically, I'm going to take you through alarm dialer basics, the protocols used, and then we'll start using the Wireshark traces. And I'll give a live demo of my implementation for HITR. And I'm also going to discuss weaknesses in both SIA HS and other protocols. And that'll be a summary. The basics. It's filled with acronyms. So basically we have alarm transmit equipment, which is basically this dialer, which uses an interface to the alarm system on this end and Ethernet on the other end, which will be transferring events to the alarm system. The ARC, the alarm receive center, which basically the instance that receives the alarms. The PROM is the unique account code for a building, basically used to identify the customers for the alarm receive center. The ATE sends the alarms, the ARC just talks everything, basically. C as the standard for alarm transmit, and there are several codes. There's actually, I think in my implementation, there's like 1,000 lines of code just to implement the codes. So basically you have like tamper alarm, tamper restore, burglary alarm, burglary restore, panic alarm, which is basically a button that means there's a robbery, that sort of thing. So, several protocols are in use for this. There's the SIA protocol, which is basically used for analog phone lines. Same with the extended SIA set, which is basically the same thing, but with a few extensions. And there's a Demco contact ID, which does not use the SIA codes, but is slightly different, mostly numeric. There are several IP protocol interfaces, which was very late to be standardized. So there are several to choose from, which is interesting. The SIA HS, which is basically alphatronics proprietary protocol. The Vibel and SEC IP, which is the Dutch attempt for a standard. Also not very secure. DC09 and a German standard as well. So, Wireshark, the fun parts. I don't know if you can read it, actually, I hope you can. Can you read the numbers, everyone? Okay, good. So, basically, this is the first message from the ATE to the ARC. So, basically, I wanted to implement this for HITR to be able to monitor all events if there's an alarm going off, or if somebody unlocks it or somebody locks it. We want to know this on IRC, and we want to log this to the database just to see what's happening. I tried to implement this, and basically I just got this. Hardeman Beveiliging Bedrijfszorg was kind enough to sponsor us with an alarm receive center, and I could capture the data going from the AT to the ARC, which is basically this. This is the first packet. As you can see here, the first part is 34, and if you look at the length of the message, you go like, could that be the length? And you verify, yes, that is in fact the length. So, first part is done. There's one problem though. I can't read this. Yes. So, anybody care to guess which encryption this uses?
Looks like some XOR cipher or
Exactly. Very good. Do you know which one?
Nope.
Take a wild guess.
With the number B6.
Yeah.
Exactly. It's B6. Aha! So, little Python script. Put everything through there. What do we get? Aha!
That's better.
See how long that took to crack that? Basically, what we're getting is some binary stuff, which is obviously the first part of the message, which is the length and some random crap. Basically, we have the ACLX 1.7 unit, which is this one, which is doing a registration request. If we look at this in the binary unxort, we also see 1255, which is the prom code. But this is actually incorrectly encoded. So this is a decimal value, but it's encoded like it's hex binary, which is okay, weird, but this helps because I found this in like 2 seconds. So that's pretty awesome. Oh no, wait. The replies, they're different. Yes, indeed. So, very good. This is the alarm receive center unit. We see a registration renewal. This is basically telling it to go to port 4008, and the rest of the communication is done on a different port, which is optional. You can also do it on a single port. But yeah, we see this again. We see the same format basically. Also with the 1255 prom and the renewal, and yeah, that's basically the protocol. So basically we have the packet length, which is unxort, which is basically just plain device name, decimal prom number, encoded as if it were hex. A message, which is different for every single message that will be transmitted. And, oh god, there was also a checksum at the end. So, this part is a checksum. Oh crap, it's a checksum.
There's a bit counter.
Not exactly. So, I tried to implement this. I mean, I cracked it in 5 minutes, just like we just did right here. But it's checksums. That one was hard. Took me 2 days. I tried every CRC10 to CRC16 algorithm with different precedes, different XORs. Nothing worked. And then I just went like, what if I just go compare the messages and put the checksum in? And so I noticed something that longer packets generally give higher checksums. And I was like, which algorithm would do that? Wait, so basically we have multiplication or addition. So I was like, no. No, it isn't. But yes, it's basically just the sum of all the preceding bytes.
Yeah.
So, I did not think of that. So, I made this implementation. A full implementation with some pluggable handlers and database event logging. Also with an IRC interface, so basically we will know everything that's going on within 1 second of the event. So within 1 second, the event is an IRC, and we will know this before we get the phone call from the IRC, because we also use an ARC. Well, the more people that will be there with alarms and stuff when the alarm goes off, the better. So if all of Armsport knows that we're having an alarm, it's good. Yeah, it's prepared for more protocols. I also started with implementation for Fable and SecIP, which is the Dutch attempt at the standard, which is also not very secure, but at least they try to do it right. So, and I'm also going to give a live demo, so hope this works. Yes. So basically, this is the web interface for the for this device. which has this nice little tamper switch, which I can use to trigger an event. Oh, wait, what did I do?
You tampered.
Right. Okay, so
Awesome.
basically,
Demo syndrome.
yes. Yes. I can't seem to. Ah, yes, there we go. I have some. This is my code, basically in debug mode, receiving the events. We have an IRC bot, which is JSON bot. We already have this a bit there. And this is, apparently I already clicked the tamper switch. So, okay. Basically what's happening is we see that the dialer is ready. It has established communications with the ARC, which is a good thing. So what basically happens is we can trigger an event, which is usually done through one of these ports, because you connect this to your alarm system. But in this case, that would be a bit much for a live demo. So basically, I only have this button with me, which is like, voila. I push this, so what it says is, hey, the alarm equipment has been closed, which is good. And we're open again. So we're getting this on IRC.
So the box is not triggering the actual alarm and
No,
feeding
no.
it back into the system, you know what I mean?
No, it had a direct communication with my laptop.
Yeah.
And you can add more dialers, so I removed the ARC for this test, because otherwise I would get phone calls. But yeah, this is one dialer, so this is the direct connection to my laptop.
Did you play around with the receiving server?
No, well I could. More on that later.
Off the record.
Yes. This is very secure. Okay, now let's see where my presentation went. There we are. Weaknesses, the fun bits. Basically, in order to have a secure protocol, you need at least 3 things, probably more, but these are the 3 things I could come up with. You need at least some protection against packet injection. Establish a session, please, because injection is bad. You need a strong cipher. XOR is not good enough.
Why do you need a strong cipher?
Well, in order to
Hide the messages.
hide the messages from eavesdroppers, and
Are they that sensitive?
well, the messages themselves are not that sensitive, but you want to be able to make sure who's it from and that sort of thing. So please do. And do identity verification, which is basically something that the entire alarm system world does not do. Not a single protocol, which I've seen, does identity verification. So even if they do encryption, it's not good. So this one was pretty bad. There's no identity verification in CIHS. There are no sessions, not really. There are some sessions with registration renewals, but it's very easy to get between it. These are UDP messages, and the interaction is completely predictable. Once you know which port you get from the ARC to connect to, it's always static. It's always the same. You always get redirected to the same port. And you can just spoof a message to it, because you can just inject things. So basically, the prom codes also, they are given out sequentially. The range is awesome. The range is between 1 and 9,999. So it's sequential, which is true for all protocols which involve IP dialing. But with CIHS, I can trigger an alarm, burglary alarm, for all the ERC's customers without ever revealing my own address. So, no, I did not try this. They don't like that shit. but I have a test prom which I did try this on, and yes, that's very easy to do. So if you know the ARC from somebody, just you can blank them out completely, because if all of their customers suddenly give burglary alarms, then by God, nobody's paying attention anymore. They just go into panic.
Fire, fire, fire! There's no fire.
Exactly. But on all the customers.
Did you already contacted the guys who created this stuff?
I did, but I received no reply as of yet.
Ah. I heard you can call RedSpace and they will make this.
I could try that.
I'll call Brenna.
Okay. There's.
There he is.
But yes, that's basically what the RC stuff is. I went ahead and I tried this, not this, but with one prompt, and it just worked. So,
Alarm be on.
yes, exactly. So injection with this stuff is very easy. Okay, so there's this other protocol, which I tried. I did not try all 4 of them yet. They try to do it right. I mean, they use RSA, and the ARC actually gives out their public key. But it will do this on every single session, and the client will not verify it. They will just use it to set up the encryption. So basically, they're using RSA as Diffie-Hellman encryption, because there's no identity verification. It's transferred every single time. So basically, just disconnect it, put in your own implementation in between, and voila, you have now access to a filter. So identity verification, yeah, missing, big time. And they try to do it right. I mean, AES is actually the right thing to do here for RSA as well. Oh well. My code is on GitHub. My implementation. So if you want to use it for good, or good. If you want to use it for evil, sorry, it's not a client implementation, it's a server implementation. But you can use it as a reference.
Put it in the code, eh? Are you evil? Yes or no?
Good point. I should make that a constant or something. You can ask me for specs on most of the other protocols. I've assembled quite a few. Yeah, give me darters. I want them. Because I want to have all the implementations.
IP or also analog?
Also analog, actually.
And GSM?
GSM is tricky. I can't do that. I could basically do OpenBSC stuff.
And tap into the logic board.
Yeah. Well, give me that as well. So, well, thank you.
Awesome.
So, questions?
Are there actually security companies that are running this stuff on public internet, or is it all behind private VPNs and that kind of stuff?
This is 100% public. There is no private interconnect between the ARCs and the ATEs.
Not completely
What?
true.
Not?
But it's 95%.
95?
They have some hardware VPN connections, but not so many.
Okay.
Yeah, well then this could only work in. If you want to use it, then you should use the VPN.
You can add a VPN with IPsec, for example, but
No.
nobody's doing that probably with their.
Actually, the way the security companies try to mitigate this problem
Yeah.
is really weird and back to basic. So basically what they tried to do was like they have with the unlock system. They tried to control every single hop on the internet to actually get a secure line. So of course this can't be done, but what they tried to do was you have a certificate on a certain line. So if you have a business connection with the internet provider, they would certify it for your connection, and they will have a direct peering on the internet. But that's obviously not the right way to secure this. I mean, you can just plug it in halfway.
You can still fake an IP address with your sessions.
Yeah, exactly.
They're using UDP.
Exactly. That's completely wrong. The wrong way to do this. But yeah, that's
So final verdict would be broken. Yes.
Very broken. All very broken.
Can we help you out to make this more? I think this needs attention. Can we help you out with it?
Sure.
Yeah.
Sure.
At what time span did you mail the customer of the vendor?
I think 3 weeks ago.
3 weeks.
Yeah.
Which is a long time.
Yeah.
Well,
If it was my system, I should give them
Yeah.
all their.
Yeah.
But you're security aware.
Yeah. And they should be security aware.
Definitely.
for response time of vendors, I think you should wait at least 2 months or something.
Yeah.
It's not the way I would like it, but
Well, they can't. But they can't patch this. It's in the protocol. It's in all the ARCs.
Yeah.
It's in all the
It's a design error.
ATE.
Yeah.
It's a big design error.
Yeah, you mentioned that you can just use UDP and spoof an IP address, but doesn't the ARC check the IP address to see, let me finish, to see whether it's a registered device? Because if it is, then you would need to know all the IP source IPs of the registered devices before you could do an all-scale attack on an ARC.
They don't. I mean, they log it, but they don't check it.
Don't check
And you
it.
can still spoof the source IP.
No, but I can only spoof your source IP if I know your source IP, and if the ARC knows your source IP because you registered,
Yeah.
and I just spoof something else, and they're gonna be like, fuck
They,
you.
they don't check it. It's not.
You test it?
I tested this. Yeah. They don't check it, but they do log it, so they can probably filter something. But if you would do this all-out attack, you would obviously not use one UDP source address. So you do that randomized,
And hope that you hit the right one for the right prompt.
No, that's not necessary. They can't filter it out if it's random.
And they can just filter the packets for known addresses and then check
But
the
then,
for
no, then
prompt.
you would also lose all the legitimate alarms.
No, because that's legitimate address.
Legitimate addresses. You mentioned there was a registration UDP packet, so
Yeah, but the registration is transferred every session.
So if your registration ID.
you just register before the attack.
And there are no registration IDs.
Okay. Okay.
So the registration is just to do a forward to one of the UDP ports, which has this service running.
Mm-hmm.
So if you have a board with the 8 units, you can actually transfer it to different cards in the ARC. That's it. There's no checking for. It's hard to filter out. I mean, if they probably could do like a filter on obviously the time span, and they can check the previous registration for everything. They need to use a custom query for that, and as far as I know, that's not implemented. No, you can create series panic.
Okay. Any other question?
The other protocol you looked at, the one that did RSA,
Yeah.
wouldn't that be easily fixed by just signing the public key and then having it checked client side?
Yeah, it would be. But you'd still need to. I mean, that way, all the security will be done client side. Server side, nothing is verified. So even if you were to just store the public key in the device, you still would have no way to check if the right device is talking to you.
No, that's true.
And in the protocol, they do use this. In SecOp, they use the device ID, which it sends out, and they use that to check for next messages. So if the device ID changes, an alarm will go off, but the device ID can't. You can spoof this easily, because if you allow the ATE to set up a session with you, if you do a man in the middle, then you already know the device ID, because you already have a connection to the ATE, so you can just forward it with a different encryption. So man in the middle doesn't protect against.
Except that the client would never set up a session with you because you cannot prove that you are the owner of the certificate. I mean, I can see that.
There's no checking for this.
If the client's not checking it.
No, if the client's not checking it, then it's not checking it.
So that's still an issue. It's hard. It would be harder, but it would not be impossible.
I think about the result of, if you want to fix this, you need to create new firmwares, new configurations, etc., etc. It's not just like doing a server-side change.
You can
You need to redo all the changes.
All your systems.
Everything.
yes, and everything at once.
And it's taking
Because
at least
this-
a year.
Also,
So
this protocol doesn't have versioning support as well. Neither do. So
Are these boxes manageable from the internet?
some of them are, but most are behind network addresses.
Okay, and do they have an update function for firmware or something?
They do.
Okay.
They do. But that would need local access on this particular device. You need to upload it through ours.
Okay.
232.
And actually that's not what you want to do if you can make a secure connection.
True.
Then everyone can just press the firmware.
True.
Yeah.
That would be nice.
No, but that's
Still, how many
okay.
customers would update the firmware?
Indeed. So even if you were to adapt the protocol so that would have revisions, it would still be very hard to do.
And you need like a sort of time span for backward compatibility.
Exactly. You need to always
No, you
apply
don't.
the old protocol
Yeah.
as well,
you
or
don't
always at least 2 years.
you then just fall back to the old protocol and the whole system is leaving again.
Yeah, exactly.
So why you would build backward compatibility? You just shoot it.
Now for the transition period, you need a transition period. You can't just
you have to
disable
flash it
all
them 2 times.
That's why we still accept web.
Yeah.
Because you can't just turn it off because people use it and you
Yeah.
can just.
The system that's in use, you can't just turn it off.
No, but you can set up 2 servers, 2 different networks, and just flash one customer over to the new version.
Yeah, but
And then that customer doesn't have to fall back to the old protocol. Then that system customer is already secure.
No, if you're running the old protocol, then
On different servers,
but suppose you're a customer, you start using the new protocol, you're fucking A-okay. And I'm like, I'm an attacker, I'm going to use the old protocol and say I'm you.
No, but if you
well, you can actually build a check for this.
you can
I mean, if
Yeah.
you can have you can map a customer to a specific protocol maybe. So
Or customer check, he's migrated to the new system.
yeah, and if you get an event for that customer on the old
You
system,
can fix it on your events at least.
Yeah.
Okay. Thank you very much, Wilco.